Take it away.
All right, I'm Tim Allclair, and I'm working on adding sandboxes to Kubernetes as a native concept. When we say sandboxes, we're talking about kind of Kata and gvisor right now, but keeping the definition open to other runtimes that might come up in the future. Um, so we're primarily driving these discussions in SIG node, but I just wanted to give an update here since I see this as an important piece of multi-tenancy. And yeah, I think I've talked about it before, so I won't go into the kind of the concept too much. But right now we're talking about what we want the Kubernetes API to look like. And the goal is to get something probably an alpha stage in Kubernetes 1.12. Yeah, so there's kind of two competing proposals out right now. The first one is a super simple API. It's just sandboxed Boolean on the pod. And this basically just gets passed through to the runtime, the CRI runtime, which then makes a decision based on the state of that Boolean, which OCI runtime to call underneath. So that would either be a native one in the case of sandbox false, or one of the sandbox runtimes in the case of sandbox true. And it would be up to the cluster administrator to set up the nodes with the desired sandbox runtime. And then there's also some interactions with other fields in the API. So for instance, we don't want to allow you to set sandbox true and also say, but I'm going to mount, the root host path and add host networking and whatnot, because then you're not really sandboxed. And the goal is to make this both really simple and also hard to screw up. And so that's kind of where those requirements come in. Yeah, so this is the really simple option. A lot of the decisions on how to configure it is just pushed to the cluster administrator or the cluster provisioner in the case of a managed cloud environment. Yeah, so that's the first approach. The second approach is kind of the more expressive, more abstract one. Instead of just a Boolean, we would introduce a new API resource called runtime class, which sort of defines what a runtime in Kubernetes would look like. And that has kind of three different classes of fields that are captured in the spec of the runtime class. One is fields that change the runtime behavior of the pod. And so this would be like opaque parameters that get passed through to the CRI runtime and aren't actually, basically annotations, but things that can be used to configure the underlying runtime. Pod overhead is another one that we've talked about adding in there. Since sandboxes tend to have higher overhead, it's more important that we factor that into scheduling decisions. And so that could be included in the runtime class as well. The other type of field are what I'm calling kind of supported fields. And so this is a way of expressing which features this runtime supports. And so this is where we could say that, this is a sandbox runtime, we don't support host networking. It also fixes a problem that addresses a problem that we have today, which is how we represent kind of optional fields or optional features that aren't necessarily implemented on every Kubernetes cluster. So for instance, AppArmor and SE Linux are currently mutually exclusive. And so this is where you could set up the cluster to say, we support AppArmor and not SE Linux, and then fail much earlier and if we can't run the requested pod spec. And then the last type of field that might be included in runtime class is just kind of informational declaration of fact sorts of fields. And so this would be something like, is this runtime using host network, or hardware virtualization? And these are things that the cluster administrator could set up just to kind of explain to the developer or whoever is actually going to call the runtime class to say, this is what this runtime class represents. But these wouldn't actually have any functional use within the system. And then finally, so you have this runtime class resource that describes the runtimes that nodes can run with. And then there would just be a field in the pod spec that says, I want to run with this specific runtime class. And of course, we would have defaulting so that you don't have to specify this on every single pod. Yeah, and then the kind of extension of that is we could have sort of predefined runtime classes. So for instance, we might say that native is a runtime class that has a specific definition. Sandboxed is a runtime class that has a specific definition, a set of requirements, and then make those part of the API. So you can expect that if you are deploying to a cluster and it has a runtime class named Sandboxed, you have some expectations about what you get from that. And we could make that part of conformance. And this is sort of kind of thinking farther into the future, but is how we can get runtime class to sort of have the same simplicity that the sandbox Boolean has. So anyhow, those are the two definitions, or the two kind of competing proposals that are out right now. I think the community is leaning towards the runtime class approach. And I'm hoping to have a discussion in Signode this coming Tuesday and sort of get to lazy consensus around that. And then make a more formal KEP proposal for the decision. Any questions or comments on that?
Seems good to me. I like the runtime one. Sorry.
Yeah, that also addresses kind of the more general case as we start adding other wacky runtimes, Windows containers and KubeVirt style runtimes and other things that people have proposed in the past.
Nice.
All right, happy to hand it off to you, Jess.
Cool. Yeah, so my doc, like as a preface, I would like to say that I'm like not married to this. I just like had this weird idea. And obviously it related to the way containers are set up on Linux and all the other isolation mechanisms on other kernels. So I kind of like took it really far. So yeah, I guess like, does anyone have any specific questions before? I mean, I could do like a brief overview, but yeah, basically I just kind of used what I knew about isolation mechanisms on other kernels and kind of redid that abstraction on Kubernetes, which is kind of insane. But I do feel like David brought up some really good points as to how the scheduler works and things that I had left out with regard to like resource control per node. So that's an interesting complexity that I didn't really think into. Anyone have like specific?
You hear me?
Yeah.
Okay. We are particularly interested in the last little bit that maybe you didn't go into as much of the isolation via, where is it? The very end, like with tenants and other kind of API access. I don't know as much about the resource control area that you seem to be owning pretty well, but we are struggling a lot with that and wanted to know if anyone else was pushing forward with like a tenant concept at all, or had thought about that last part.
Yeah, I mean, personally, I think most people thought about it in terms of just using RBAC and the mechanisms that we have today. But I'm not like fully confident in just doing that, just because if there's one bug, then you have to upgrade. But I'm not sure if, has anyone here like deployed anything like that?
Hello. I'm not sure if I got the question right, but by reading Jess's doc, I got the impression that there is this premise that we would run Kubernetes in Kubernetes. Is this correct, Jess?
Yeah, so it is like a nested Kubernetes, which is a little gross. And there are, I saw some GitHub repos that actually do like nested Kubernetes, which I forget the names of now.
Yeah, so if I got the document, that premise right, so the answer is yes. There's people out there, well, not running it in production, but Kubernetes in Kubernetes is definitely a reality. I'm sure, did someone here read about, what were there, Giant Swarm? They were doing it, but they were using VMs for isolation, but it was still, they would still do this kind of separation. At Mesosphere, we're looking at something similar. We are just not, and this is something that I just read today on your doc about the tenants that span multiple namespaces. This is something we haven't tried, but everything else we did, and we actually have proof of concepts that run this. So potentially we want to go there, but that's why I'm here for the first time, to actually engage with this working group and share our experience, and maybe hopefully learn a lot from you guys as well.
Yeah, that's cool. The question in the chat is also similar. It's like, it seems quite close to running the tenant Kubernetes in a provider Kubernetes namespace, which, yeah, it is. It's totally similar to nested. And I looked at a lot of the nested code on GitHub, but I didn't like vet it. So that's why I just didn't say like, use this thing. So yeah, it is very similar though. I mean, you just basically have to give each tenant their own API server URL.
Yeah, the only difference on our end, to be very straightforward, is that the ring 0 Kubernetes is not exactly Kubernetes, but that's just an implementation detail on our end. But other than that, the design, what I really, the conclusion I wanted to share with you is that we agree with this design, and we think that what Tim is proposing actually, you also mention it in the document, so it makes a lot of sense. Both of the documents make a lot of sense to us, well, separately but together as well.
Yeah, and also in the chat, from the analogy of the nested kernel paper, I was thinking about it as like actually integrated into Kubernetes and not like a thing on top, but like that would take a lot of work, to be honest, and especially the like kind of abstract clone, this is called, for Kubernetes, would be creating namespaces that would take a lot of work, just in terms of like the etcd and all those services that you have to spin up. Is there like a real use case for this is actually what I'm wondering, because it's not like we had one. I just did this because
yeah. We have for sure a real use case for this.
For parts of it.
For at least for parts of it. Yeah, going forward, we want to think about the resource isolation, but for right now, the main concern we have is making operators and specifically CRDs available to more than one namespace, but not the entire cluster. So that would require at least multiple API servers.
Or some other kind of isolation mechanism at the API level.
So I haven't looked at the existing like Kubernetes and Kubernetes projects, but I suspected that they don't spin up multiple API servers with the same scheduler. And if they spin up multiple schedulers, I doubt that the schedulers do the right thing on the nodes.
Yeah, that was also my concern. And like the whole, actually the aggregated API stuff, like a lot of those were using that. And I was like not entirely comfortable with like what aggregated API was doing.
Yeah,
I don't know if you all had looked into that, but.
Yeah, like I said, I haven't looked at the specific projects, but.
Sorry, can you explain the use case again? I didn't quite understand with the CRDs, something about, yeah.
Right. So if you're using if you're using Kubernetes features like CRDs or aggregated API servers, when you install either the CRD or the aggregated API server, that registers an API globally for the cluster. So in a multi-tenant scenario, you might want tenants that have multiple namespaces, but don't all see the same sets of APIs from the Kubernetes API server.
So I think. But the CRDs can be namespace granularity also, not just cluster. Sorry, I was saying CRDs can be namespace granularity, not just cluster level. So couldn't you, in a regular Kubernetes cluster, just register like a CRD per namespace for each tenant that you think wants to use the CRD?
So namespace CRDs are kind of a misnomer, right? Because it's actually the CRs, the instances of them, that are namespaced, not the definitions themselves. So if you create a CRD like foo.kubernetes.io, now everyone on the cluster sees an API service called foo.kubernetes.io, right? That's global.
Oh, I see. Somehow I never quite understood that subtlety. That's interesting. All right, thanks. That makes sense.
Mm-hmm.
And then I guess your point with the aggregated API server is that it's also a globally registered thing in a similar way. Is that what you're saying?
And it's not extensible. The nice thing about how operators and CRDs potentially could work is letting the tenants themselves kind of extend the API, so to speak. Where doesn't even seem really like possible without custom work on an aggregated API. Makes sense?
Yeah, I mean, it's a much higher privilege thing if you're creating a cluster-wide resource versus a tenant-wide resource, right? So.
Yeah, likewise, it would be useful for things which aren't currently namespaced, like initializers and mutating webhooks.
Definitely.
So that seems that only having namespace or cluster-wide scopes is not enough, and we maybe need new scopes.
One way to do it could be with new scopes. I don't think there's like an easy transition path for the Kube API server to deal with that. Like the path of least resistance seems to be to do something that lets you have multiple API servers rather than making the API server aware of all these different things. But it's a very cursory look at these issues, so I'm not willing to stand by that statement.
Yeah, I'm just trying to understand something here. From what I get from Jesse's doc in particular, the proposal is to clearly segregate, for instance, two separate Kubernetes clusters. You have one which is a ring 0 that is used to schedule these two other clusters. But they are separate. So each one of them has its own API server, its own control plane, its own Kubernetes nodes. So maybe looking at this, the drawings, if we're reading the node would have to run, let's say, 2 kublets, each kublet belonging to different clusters. So this is one idea, and please, Jess, correct me if I'm wrong here. Another thing is to have 2 tenants of the same Kubernetes cluster, which I believe is a different use case. And I believe that's what you're bringing up. At least this is what I'm understanding. Am I wrong here?
that was the use case we were bringing up. Definitely there's some overlap with that and actually running multiple clusters. And this probably overlaps some with like the multi-cluster working group as well. Yeah.
Yeah, that's interesting. I didn't think about the whole multi-cluster working group. I have no idea what they're doing.
So I'm trying to think about this in terms of the threats that we're defending against, and I agree that it seems like having the sort of the multiple control planes protects us until we get to running pods, right? And then you start interacting with the kubelets, and the kubelet is sort of like the crossover point between those control planes. We could solve this by running multiple kubelets for a node, but then at that point, we're essentially just running multiple separate clusters sort of overlaid on the same set of nodes. Is that sort of the desired state of having essentially separate clusters per tenant, but sharing node resources for better utilization?
From our perspective, from the stuff that we've been doing at Mesosphere, we are walking towards that solution. I'm not saying it is the correct solution. We're still trying to make it work properly. The kubelet and is not implemented to run as a container that does not have access to a lot of things from the OS. So, but yes, that's where that's the terrain we're trying to learn about.
Yeah, like one of the main things that I was thinking about when I did this was like, as you can see by like the first two iterations, like there's really not much that you gain versus like in ease of operability for the clusters. Like you don't gain much unless you're in the third scenario where you are sharing resources. Like you might as well.
Operability though is like our end game. It's like what we're trying to do.
Yeah, it's hard to solve that for this like scenario and actually keep things isolated. Like the struggle is real.
Actually, there's one other use case that would a multi-cluster within a ring zero cluster would allow, and that is allowing users to list namespaces. Currently,
yes, please.
Because then it's a question of observability objects, and a number of users come to us with this very nice Microsoft tool which requires such features. So giving them each one of them a cluster that looks like just a normal cluster that fits all the documentation they find online would be a benefit for us. It just looks like they have their own, but they don't, because they cannot be trusted or they don't have the experience in actually running a production cluster. So there's a usability, user experience use as well.
Yeah, and also I think I had made a comment in the doc about like kind of from the, I guess this is related to what you were saying, but like from the cluster admin perspective, like it's almost like they're managing, n different clusters, one per tenant, since there's, n different API servers. So I think one of the challenges is like, how do you do the management without kind of building federation on top of the inner clusters, these nested clusters, right? Like it's, yeah. Because in particular, like all of the information about what's going on inside each nested cluster is hidden inside the API server for each nested cluster. And so if you want to somehow expose that, you have to pull it out of each API server individually. And so then that starts looking a lot like federation or, you know, whatever people are doing today to manage multiple clusters.
Totally, yeah. And that's actually where, like, if this was implemented and there were bugs, like, where you could escape your namespace, like, that would probably be where they lie, is wherever we decide to expose data. Because, like, you're going to have to either combine, like, the etcd instances. Like, if you want this to be manageable and operable from, like, the root zero, like, the ring zero, like, you need to kind of aggregate all the data, which was why I started looking at the aggregated API, but I did not feel comfortable with how that was working.
Yeah, and I think, I mean, this is sort of a common theme with some of the comments. Like, once you start doing things for efficiency or manageability, like having a single kubelet per node, like Tim was saying, or a single etcd across the whole cluster shared by each of the inner clusters, then you start to lose some of the isolation. So it's kind of like a trade-off there between the, you know, between the isolation and I don't know, manageability or, you know, efficiency in some sense, with like completely separate clusters on separate nodes on one end of the spectrum and regular Kubernetes on the other end of the spectrum, and then these different points in between.
Yeah.
I would be interested if people do have an opinion of how this has worked out in Linux, when, you know, operating systems went through a similar problem of multi-level access controls. And I don't know if that was actually ever fully resolved, but were there things that worked better or not in that situation?
Yeah, those were things that I was trying to think about. But it was more along the lines of, like, get it configured correctly the first time versus giving everyone the options. But yeah, like, there are problems with just in terms of actually auditing containers. Like, there's still patches being made to the kernel to add auditing, like, so that you can know which container is doing what, and then you can track it down. So things like that, like, we don't even have that today with containers. So like, those are the hard problems.
I feel
Yeah.
like one of the
Is there
things
anything we can rule out as an approach? Just, it sounds like multiple kubelets wouldn't work because they wouldn't know about what resources they should say they have, right?
Yeah, I don't think I was thinking multiple kubelets. I think that the kubelet was, in my scenario, I was going to have to consider it safe. But mostly that's just because kubelet just pulls from etcd and then updates. So there would have to be some canonical source of etcd.
Mm-hmm. Well, kubelet talks to the API server. It doesn't talk to etcd directly.
Oh.
Correct.
Yeah, and so sorry, when you said canonical etcd, like, all right, let's say instead canonical API server, but are you saying then that you mean a single API server? Because I was assuming that that you would still have the separate API servers, so the kubelet would pull from multiple API servers. I mean, it does introduce various problems with, like, scheduling and stuff like that, but I was just trying to understand what your thought was on that.
Yeah, I'm not sure, actually, honestly, the best way to do it, because I'm not entirely sure how that works today. But the easiest scenario would be probably the one I would go with.
Because I think sorry, go ahead. Sorry.
Oh, I mean, is there a way that, like, kubelet talks to multiple API servers today, or is it just a one-one communication?
I'm pretty sure it's just one-to-one. I think that I'm sure you could hypothetically make it talk to multiple API servers, but, like, if you had it one-to-one, then what would be the difference between that system and what we have today? Like, if you have a single kubelet per node and each kubelet is talking to the same shared API server, like it seems like you lose the isolation. I thought a lot of the isolation came from having one API server and etcd per tenant. Or maybe I misunderstood, but like, does that make sense?
Yeah. Like that totally is the gain. I just wasn't sure exactly if the real implementation of this and not just like the hypothetical thing in my brain was impossible.
I would definitely prefer that the kubelet be as dumb as possible when it comes to the level different namespace, access, whatever, if possible, and rather have, I think the problems come when the kubelet is acting and pulling information on behalf of users. Can we, maybe we can isolate to that problem? Like, I don't know that it's an issue that it has a cog to schedule, but it might be more of a, like a separation issue when it needs to actually pull the container, for instance.
I'd like to add a couple things. While making the kubelet, enabling the kubelet to speak to separate API, Kubernetes control planes, because the kubelet can point to, let's say, a load balancer that has a bunch of API servers behind it. The API server is stateless for as long as it's the same, it's part of the same control plane, it still works. But there is another channel of communication between the API server and the kubelet, which is used. So let's assume that now we enable the kubelet to talk to two separate Kubernetes control planes. Then the users from these from the separate clusters can then access the kubelet directly. So doing something like kube control exec, kube control log, kube control port forward. That's a channel that the API server proxies to the kubelet, because the kubelet itself has a small but important API server there, not a Kubernetes API, sorry. But so that would be breaking the isolation, because in theory, user 1 and 2 from these separate clusters could then reach the workloads that the kubelet is managing. The kubelet does not understand namespaces. The kubelet doesn't do isolation per se. The container runtime does.
Yeah, so in this scenario, like you would have to trust the kubelet, and that would be something we would have to vet, like all those functions with exec and logs. And like I looked at a lot of those when we did virtual kubelet, and like they aren't really all that complex. So I feel like that was a like surface area that we could actually dive into and make sure was safe and like fuzz all of it.
I think we're eventually going to need to sort of overhaul the kubelet's APIs. We've talked for a long time about reusing the API machinery within the kubelet to support those APIs. But as you say, the kubelet doesn't really care about namespaces right now. You know, if we ever want to have multi-tenant logging and monitoring, for instance, you know, outside of what we're talking about here and maybe multiple kubelets, like we would need to implement some sort of namespaced version of the monitoring and logging APIs, and then have authorization on those namespaced versions. And so I do see us eventually getting to a place of having kind of namespace aware kubelet APIs with finer grained authorization on them. Do you think that that's more likely than, say, introducing a different type of scope, let's say scope tenant? Tim? I think we're more likely to be consistent with the Kubernetes APIs. You know, if we introduced a concept of tenant into the Kubernetes API before we got to this at kubelet, maybe we would consider it. But I think right now namespacing is the grouping that we would use.
So it kind of seems to me that without having if the isolation doesn't go all the way down to the bottom, having the multiple APIs is kind of like an API per tenant is fairly extravagant. And wouldn't you kind of, leaving aside things like in separate CRDs per tenant and stuff, and the fact that you'd be putting all of the complexity in one place, but this kind of goes back to one of the original SaaS versions of multi-tenancy, where you've actually just got another API in front of it that does all of this management level stuff. Am I missing something, or are we just kind of doing the same thing but a different way?
Yeah, I guess like at some point you do have to trust something, like it says in the chat. And whether that root of trust comes from like as low level as like a hardware component that's a TPM, or you decide to trust the kubelet. Yeah, we would have to decide what we wanted to trust.
And I think there it would be useful maybe to step back a little bit even and like say, what is the threat model? What do we really need to have shared here? What are common resources? What must be isolated? Because we're talking very much about implementations in the context of current implementations versus where we want to be relative to the threat.
One thing I want to note, it's not always a threat model so much as a operational model. Sometimes these are about the concerns are for being able to manage the cluster rather than necessarily like being super concerned about the like hard isolation.
Well, I think it's a trade-off with them both. So like the threat model that I was thinking about was like the logical bugs in API server, because that's what people have access to. Like since the only thing exposed to them, like they don't see the kubelet API. Like the API server talks to the kubelet. So like we should trust our own components there. But like the actual user talks to the API server. So that's where if there's a logic bug, they could escape the API server, hypothetically, but then you would be still in a container. So then you'd have to also escape the container, which is hard. So there's that. And then the other entire aspect is remote code execution in containers themselves, which is, something that we have already thought about a lot. So like those are the two things that are actually exposed to tenants. So like when I thought about it that way, like the kubelet and everything really underneath was more a concern with, do we trust our components to talk to our other components?
Yes.
And I think that's what I was trying to imply with the threat modeling, is that we kind of have a loose component diagram or flow of the cluster or tenant namespace CRUD operations against the cluster, and that those are implicitly untrusted at first until they've gone through some validation, but then if they're validated, can interact with the core.
Totally.
Yeah, I was thinking the way I've been modeling it is there's the kind of object, you can have cluster state, the application state, other shared state, communication data, and we want to control all these kind of links between the clusters, the apps, and external environments. Does that seem, I don't know if that makes sense, but
yeah, I think
our part is app to cluster right now for, I think, what I was discussing.
Yeah, because like technically, I mean, in any hypothetical scenario where you're like attacking the kubelet, like you would have to use an API server bug that then affected the kubelet. So it's kind of more complex.
Well, the kubelet does have, like Tim was mentioning, like various people were mentioning, like it has its own API. Well, not a true API server, but it has its own HTTP server that's serving these, like, the exec and attach and these different endpoints. So those also have to be hardened against attack. Maybe they don't have to be multi-tenant if, the stuff only comes from the API server. If the only thing connecting that in that direction is from the API server, but there still is a surface to attack there that needs to be considered because it is running a HTTP server, right?
Totally. I was just more thinking about the fact that like it's not the tenant directly connecting to it; it's just another one of our components. So we kind of control that communication.
Yeah. I just meant like you need to make sure that the tenants can't connect to it. That was my only point. Yeah.
Totally.
But in terms of like the threat model and the benefits and stuff, like, I mean, I think a couple of other benefits of it are like, it solves this problem of how you can have multiple tenants have the same namespace name, which is something we've never really figured out how to do in Kubernetes. Like in a normal Kubernetes cluster, you would need like hierarchical namespaces, or like someone was mentioning before, a new tenant concept where the tenant then could have its own set of namespaces. So like, you know, one thing this does give you is any tenant can choose any namespace name without worrying about collisions, because they each have their own API server. And then the other one is kind of like these other control plane components like DNS, where there can be information like leaked between tenants today, like all the service names are in the same DNS and something like that. Like it wasn't explicit in the design, but I was assuming that just in mind, like you could potentially have a separate DNS, or maybe it was mentioned in the design, but like a separate kube DNS for tenants. And so that kind of solves that problem of like service and pod names leaking across tenants. So I think this does solve like those a certain class of problems about like information leakage and the namespace name collisions and stuff. I think the question is just like, is the cost too high in terms of the operate like manageability and that kind of stuff, and resource consumption and what have you.
Totally. Yeah, I completely agree. And I put the DNS thing, except I shoved it off in a separate Google Doc. But yeah, we need to namespace kube DNS for sure.
Well, it's just an add-on, right? So whatever add-on that is deployed per cluster or isolated. So the way I see it is, and the way I read Jess's proposal is, we have a separation of clusters, while not a separation, a new layer of separation in the API itself. That's why I mentioned, maybe the possibility of maybe having a tenant object that would scope object, that would then, as David was mentioning, would be like a top level object that then could have multiple namespaces. That would also address usability from an user perspective, using kube control or just the API. With authentication, this user belongs to tenant A, B, or C, or two tenants, I don't know. But a lot of these things, and David mentioned cost, even if this concept is added, every component that I can recall of, controller manager, just enforcing quota, services, endpoints, whatever, the cost would be on the complexity of the code. You would have to write a lot of code to understand this tenant. At least that's how I see it. While on the other end, what Chess is proposing, again, the way I read it, is multiple clusters. So the cost is on the operation side of things. Kubernetes is not easy to operate, but yeah, neither is contributing to it. So not because, the community isn't great, the community is great. It's not that. It's just that there's a lot of code to cover if we introduce this kind of object.
Yeah, totally. I mean, like doing it as namespaces, I mean, I'm not obviously married to that, but I did like how the abstraction was the same as the kernel, just in terms of that. But yeah, that would be like, all of this is just a lot of work in general.
I'm not sure that I've been thinking about the idea of a first-class tenant and multiple API servers or clusters, however you want to think about it, as being mutually exclusive. I've been thinking that there would be a top-level concept of a tenant and some API server that I can talk to find out about the tenants and what namespaces they own. But then there would also be, for each of those tenants, a separate API server with separate authentication credentials I can use to talk to that. And the design of how that happens, would like whether they share the same etcd or they have their own etcds and things like that. But I guess I assumed that those things were not separate. And it sounds, Paula, like you assumed that they very much were. So just to point out, that's an interesting difference, how we've been thinking about it.
Yeah, I thought about it both ways, and I'm not actually sure the right answer when it comes to etcd. Mostly because when I looked at the aggregated API stuff, sorry, I keep bringing that up, but like it like blew my mind. They spit out etcd like everywhere, and it's kind of concerning.
Yeah, I don't know though if we should say the problem of that they're required to manage their own state. That might be an implementation detail rather than a requirement, depending.
I guess one question that any multi-tenancy discussion needs to answer, right, is should there be a user that can see more than one tenant at one time, right?
Or one namespace.
I think that influences how we talk about this.
Yeah, so that's when I was getting into the really weird hypothetical stuff where we like re-implement setness. Sorry, I like for some reason thought about this as syscalls first, so it's a weird place in my mind. But yeah, no, I think it's entirely possible. And you have like the operator at the like ring 0 level who hypothetically can see everything, but of course that will take a lot of work to make that secure.
Right, so if we do, if the multi-tenancy solution involves essentially multiple separate clusters that just share the same underlying nodes, then the person operator managing all of those tenants needs to manage, n credentials to talk to those things, right? Which may or may not be a good thing.
Yeah, so I mean, so that I think is the analogy people were bringing up earlier, like with multi-cluster and federation. It's a very similar issue where, like, you want to do operations across many registered clusters, and so you have that same issue. How do you get a list of all the clusters? How do you store the credentials to access all those clusters? So, like, I definitely think there's an analogy there with the multi-cluster stuff.
Yeah, totally. Like, actually, I had multiple versions of this. The first one was like, here's how it could possibly be done. And then I showed it to Gabe, and he was like, that's just multiple clusters next to each other. So then I changed it, and I was like, here's the sad truth in that this is not possible. And then I was like, well, you can make it a little bit better. But yeah, no, it's not great. Like, the operator feels all the pain in this regard, so it kind of sucks.
I think one of the reasons I keep coming back to maybe the idea of tenants or other things is that one of the reasons that these problems are so hard is that we don't have a sort of all or nothing namespace or cluster level scopes, and we don't have any primitives to build more varying access levels upon. And maybe if we, like, rather than trying to solve every problem, if we can try to have some of the right primitives that people can build on, that would be a better way forward.
So,
yeah.
like, what, like, in particular, what kind of primitives would you start with? I didn't completely understand.
I think like the tenant, having a tenant, a grouping of users that you can, well, that is essentially namespace, but is separate from namespaces that you can then build relations with, would be probably a good start.
Yeah, it would be good if, oh, sorry, go ahead. Sorry, whoever was talking.
I was just going to say, does that kind of get it back in just into the hierarchical namespaces again?
Yes, in a way. It's limiting it to one, though.
Okay, so that, yeah, okay. That's like the graph.
Hierarchical names, all right. Another difference is that we don't have to have a namespace to tenant relationship be like one-to-many or whatever. I don't know necessarily what it should be, but it might make sense that there are some shared namespaces and shared other things if we think about namespaces as really grouping the workloads, just like we can have ways that we're grouping the nodes, we need ways to group the access controls in a way that's like reliable and actually forms a real topology.
Yeah, it would be good to understand exactly how people are using like some tenant concept. Like I know that people for sure have made up their own and are implementing it different ways, like either implicitly through the RBAC rules, or I guess people in this working group have talked about they've created an actual concept, I guess, as a custom resource or something, and so like maybe if we understood better like what people want that tenant concept to do, then we could figure out like what the right way to implement it is. Because it does come up over and over again, but I don't know if we've ever written down in one place like everybody's view of or requirements or what they're already doing in terms of like a tenant concept.
I mean, so we have a bunch of internal requirements and notes about tenancy that I could clean up and share more publicly, but they're very much our requirements and not everyone's requirements. So if that's
Sure,
a good...
but if we could pool like everybody's thoughts on it, it would probably be a good starting point. I don't know. It seems like it could be.
Yeah, I have no problem sharing ours either.
Sounds like a good action item.
Yeah, we could probably do it like in the next 2 weeks or whatever, in the next meeting.
I cannot promise, but I'll try to get the people from Mesosphere who are actively designing this to provide some feedback here as well.
I think probably based on timeline, it usually takes one more meeting to get people to do it, and then the discussion is the next meeting after that. Does that sound about right?
Yeah.
By the way, just like going back to the Mesosphere thing, you had said earlier you were doing multiple kubelets per physical node. Is that right?
That is correct. Well, it's not production. It's not yet out there, but it's not something that is secret. It's something that we've been working on. We've engaged with some people from SeekNode, etc., to try and plan for contributions upstream that would allow the kubelet to run, and some changes to CFIs that would allow them to run properly in a containerized environment with C groups, which, by the way, obviously wouldn't work with Windows. But yeah, we got it working with C groups, namespaces, and yeah, that's basically it. Unfortunately, Mesos, which is the thing that we use to run the Mesos containerizer, which is the thing that we use to run the kubelet as a container, does not support things like kata containers or gvisor. We're looking at kata containers, but it's still like up in the air. But yeah, but we got it to work. Yes.
New York.
Yeah, I was gonna say somebody either lives next to like a hospital or a police station, or in a very dangerous city.
It's Core OS.
Yeah, it's just Broadway.
Cool. So I guess like we'll take it as the action. We'll take as the action item for like the next meeting to kind of all think about, or like come back with what people are doing with tenants, I guess.
I'll just chime in here that, here at Akamai, we're just getting started with implementing Kubernetes clusters on top of VMs, on top of bare metal, but it's definitely multi-tenant in the sense that they're all running on the same physical hardware. But we'll definitely be able to share our requirements as well.
Cool. Dope. Okay.
Yeah, I guess that's another way of doing the isolation, like where you'd have multiple VMs per physical machine, and each one would have its own kubelet. And so instead of having multiple kubelets running directly on the same physical machine, like that seems like a lot simpler from a resource management perspective, because then the kubelets don't have to know about each other. It's like a way of statically partitioning the kubelet, the node resources across the kubelets by putting them each in a separate VM. I mean, it has the disadvantage of then you have statically partitioned the physical machine based on the VM sizes, but like it's more straightforward how that works with today's kubelet, because like today's kubelet expects to be the only thing on the machine, basically. I don't know.
How is that different from just running multiple clusters, though?
It is actually running multiple clusters, but we'd like to do things more efficiently and manage the security policy, which is taking it all in aggregate rather than having to manage them all separately.
Mm-hmm.
I'd also like to add that we must not forget about kubeproxy. If you're using kubeproxy and you also need it side by side with the kubelet, otherwise things won't work. So
yeah, two things writing the IP tables is not going to end well.
Well, that's thank God for Linux network namespaces.
Nice. Okay, so cool. I guess we'll see everyone in 2 weeks.
Well, if someone starts a document, I believe it's the people from CoreOS that was suggested that they would share something with us, or if they could start like a document and share it with the rest of us over Slack, that would be great, or over the discussion group. If nothing happens over the coming 2 weeks, and if I find the right people around here, and if they're available, I'll try and start that up. And yeah, let's discuss from there, because I definitely think that defining what the tenant really is and the requirements will help us define better what we need to do.
Yeah, we'll send out a doc, either send out an empty one right away or fill it in a couple days.
Yeah, we'll fill one in a couple days, filtered from our internal stuff.
Cool.
Thank you.
Okay, everyone have a good week.
Bye.
Bye.